Hey everybody, welcome back to Computer Science 3200. Today's a pretty cool day. We get to talk about assignment 1. I'm always really excited about this. This might be, I don't know if this is my favorite course to teach. Maybe it's tied with my game programming course, but I really enjoy the assignments in this course, and I think that you will too. So we're talking about assignment 1. And just up front, if you are not a registered student in the course, no, you will not receive assignment 1. It is only for registered students, and the reason for that is because it's a very complex assignment architecture, one that I cannot recreate for every term that I teach the course. And so if you're not in the class, you can follow along and see what we're doing, but you will not be given the assignment files for any reason whatsoever. I always receive a bunch of emails about that. For students in the course, you're going to have a week to complete this assignment. That should be more than enough time. But please do not wait until the last minute, because there are going to be things that you're going to need to figure out, especially if you're really new to JavaScript. We're not going to be going too in depth with JavaScript specific features, but it can be kind of annoying if you've never used it before. So let's hop right into it. So everyone should have a working link that they've been sent to their email where they can download the assignment zip file. Inside that zip file, there are a number of other files. And so what I'm going to do now is I'm going to open that assignment and we'll walk through it together. So first of all, when you get the assignment, I know that this is a little bit small. I can't really do anything about that. It's Windows and I don't have resolution scaling on. So you're going to get a bunch of files. You will get all of these files minus the solution code. I haven't given you any solution code. We will talk about what all of these files are once we get into the second part of the lecture, which is going to open up the code and we're going to explain everything. But first, I'm just going to show you how it works. But actually, I forgot to open the live chat just in case we have any questions. So let me go open that chat real quick. And then I will continue. This will just take 30 seconds. Way less than that. 10 seconds. I'm already done. All right, perfect. So let's open the assignment and we'll see what it's all about. So you get these files. The files that you get, there is a text file explaining the marks. I'll go over that toward the end. So once you know what the assignment is about, I'll go over the marks. There are a number of .js files. Those are JavaScript files, and we'll talk about that in a little bit. But the main file here is this index.html. And so this course is an algorithms course. So the choice of language doesn't really matter that much for implementing the algorithms. And the reason that I went with JavaScript for the language, there's a few different reasons. One is because HTML and CSS give us really easy tools to build really functional, beautiful user interfaces. And JavaScript is a fairly simple programming language that will allow you to do a lot of things. The two main annoyances of JavaScript is that JavaScript is not going to be quite as fast as a natively running language, something like C or C++, but it's surprisingly fast, especially if you're using Chrome. So I personally use Firefox. If you use Chrome, you'll have an even faster experience with JavaScript. So all we have to do in order to open the assignment and view what we want to look at is to just double click this HTML file or to open it in your browser. So if I double click this HTML file, it opens right in Firefox, and here it is. This is the assignment. And let me just zoom in. So first of all, this is the user interface. These black lines can be a little bit hard to look at sometimes. So up here in the top right, there is a toggle grid function. Okay, so we're just going to click toggle grid so this looks a little bit nicer. And this user interface is what I am giving you for assignment 1. So you saw that there were a number of files in the zip file. The vast majority of those files have to do with building this user interface. And there is exactly one file that you have to be concerned with, which is where you are going to implement the algorithms that we talked about in the last class. So let's do a really quick tour of this user interface. So let's look at the instructions first. That's a good place to start. So search visualization instructions. Left click and drag to start an end and goal tile. To set start and goal tile, sorry. First, what I'm going to do is I'm going to change this from student down to solution. So you are given a solution code for this so you can see what it's going to look like. So it says left click and drag to set start and goal tile. So let's left click here and we'll drag to set a goal tile. And look at this. We can actually see pathfinding in real time. So what does this mean? So you can also click once and then click again, or you can click and drag to see it in real time. Let's turn on the grid really quickly. So we have this environment, and this is a pathfinding environment. It's called a grid world. So a grid world usually just means that we've chopped up our environment into a number of grid cells. Each of those grid cells has some associated value, and this creates some sort of environment that we can do pathfinding in. So in this environment, if I refresh, so I can hit Control-R to refresh, down here there is a visualization legend. So it says that if a tile is blue or green or gray, this is what I'm calling a terrain type. And the object can move entirely within a color. So for example here, the object can move, let me select the solution again. The object can move only entirely within one color. So for example, if I click in the green and then click for an endpoint, it finds a path that is entirely within the green. If I click the gray here and I click over here, it finds a path entirely within the gray, similarly with the blue. If I try and click a start point right here in the blue and an endpoint in the green, you'll see that there's no path. Okay, it doesn't work. So if I click and drag, it doesn't work, it doesn't work, it doesn't work, because there is no path possible. So you can think of this as, now all this is representing is just a color, okay? So there's just an integer there in the grid, and it essentially says that an action is legal if we move to the same integer. But in order to make this look a little nicer, I've just colored these to make it sort of look like an environment, okay? Now, up here in the environment map, you can actually select a number of different maps. So this is the default. There's like a small maze here, and we can actually see it like pathfinding and solving the maze. We also have like a StarCraft map. So this is a really large map. It'll do pathfinding in this StarCraft map. We also have a completely blank map, which is not very interesting, but it might be useful for debugging. And I also have this little L-shaped map here, which is really nice for demonstration purposes. So here, if I click here and then I click down here, you can see that it finds a path around that obstacle. So this solution code is provided for you. It's obfuscated. As I said before, please do not try and de-obfuscate the solution code that I gave you, because it's done in a completely different way than I want you to do the assignment. So it will actually be about 10 to 100 times harder to do the assignment by cheating by trying to decompile the solution code. It's really not worth it. It's not a challenge, it's just really not worth it. So don't try and de-obfuscate that, and I'll show you in a bit. Here we have some more options. So this is an object size. Right now, our object only occupies one grid cell. In assignment 2, we will talk about objects that can occupy multiple grid cells. Here we have another thing, which is legal actions. In assignment 1, we only have up, down, left, and right as legal actions. In assignment 2, we will have octagonal actions. And right here, we also have a visualization option. So if I go back to the default and I click a start and an end location, you can see that it instantly computes the path and shows the path. However, I can change that here if I go to the visualization option. So if I say instant path plus open and closed, something I didn't say is that the red here on this visualization, that is the closed list. So those are the states that have already been expanded by the algorithm. We talked about the closed list last time. And the yellow here, that is the open list. So those are states that have not yet been expanded. So if I just change this to instant path only, it no longer shows the open and closed list. And so that's a little bit nicer visualization. Okay. If I choose animated search and then I rerun the previous path, what it does is it shows the search algorithm happening in real time. Okay, so I'm actually going to choose the L-shaped path for this. I'm going to click a start here and a goal here, and you can see how the search algorithm, the breadth first search, runs in real time to find that path. If I change it to depth first search is a completely different monster. Okay, we're going to talk about that a bit later, but that animated search is there to show us how the search actually works. Okay, and I'll do a bunch more search stuff once we get into heuristic search, but that's what that is for. Also, if I click single step and then click rerun previous path, what that does is it allows me to step through my program doing one iteration at a time as the algorithm is running. Okay, so this is a really, really good tool for you to be able to debug your algorithm, is to use this single step functionality. Okay, the last thing in the visualization is down here, and that is this sort of, there's two more remaining things. The first one is the visualization here. So if I go back to the default and I go instant path, open and closed, and then I do a path, the results of that search are here in this little table. So it says, okay, the search was breadth first search. The start was X location 25, Y location 5. I'll talk about that in a little bit. Here is the goal location. Here is the total cost of the path that was produced. I'll talk about that as well. The closed list had 1,434 elements in it, and states in it. It took 15 milliseconds to generate that path, and that would probably be 1 millisecond if I was using Chrome. And the number of nodes per second that my search algorithm can do is 96,000 nodes per second, and it's much faster if it's in Chrome. And the very last thing is that in my user interface, I have provided for you testing functionality. Okay, so if you hit run tests, I've got a number of sample start and goal locations that have been selected, and you can tell whether or not your algorithm works correctly just by hitting run tests. Okay, you can also hit random tests, and it'll run a bunch of tests between random start and goal locations on the map. And if you hit this button a few times and everything is green, then it means that your algorithm works correctly. So you know if you hit run tests and everything is green here, then you know you are getting at least 80% on the assignment. Okay. Oh, need to stretch my back. Okay. The last thing that I'll show you is what happens by default when I just load the assignment. Well, we have 4 options here. We have student BFS and DFS, and we have solution BFS and DFS. If I choose solution, it gives me the correct path. But if I choose student, it just gives me this L shape. Okay, so the student code, the reason it does this is because the student code is not finished yet. In the sample code that I've given you, I just create this L path. It's your job in this assignment to turn this obviously incorrect path into the correct path by implementing breadth first search and depth first search. Okay, what else is there that I should show you? That's it for now. So what I'm going to do now is I am going to, and if I select student BFS and run the tests, you can see here that some of them are correct. And that's because the some of them that are correct are like this, where that L shape happens to be the right path, even though you're not running the algorithm. But all the other ones, like this one, for example, that path is obviously not correct because it goes right through the terrain. And so you can see here that the vast majority of these are actually red. So that means that they're incorrect. And just because 7 of the 20 of these default ones work, it doesn't mean you're going to be getting like a 30% on the assignment if you do nothing, okay? We are actually going to be looking to see if you're implementing the algorithm, etc. And if you do random paths, very, very rarely will they actually be correct. So it's the random paths that will get you. Okay, so that is how you launch the assignment. That is an explanation of the user interface of the assignment, and that's how you're going to interact with it. So let's get into the actual code of the assignment. So what I'm going to do is I'm going to use vscode. It's not Visual Studio. It's called vscode or Visual Studio Code. You can use absolutely any text editor that you want for this course, okay? So for example, if I brought up Search Student and I just hit Edit, okay, I don't want to do that. If I just hit Search Student and used Notepad to edit it, that's fine. But I'm going to use VS Code because it's just a little bit nicer of a text editor. So what I have done already is if you go into VS Code, this is a lot of text already, I understand, but don't worry. And in VS Code, if you hit File and then Open Folder, you can open a folder as a workspace, and that will just do this. So then all the files that were in that folder are here on the left, and you can open any of them and they'll open over here on the right. Okay? So this is VS Code. It's a nice text editor. You do not have to use VS Code, but I'm going to use it because it's kind of nice. All right. So the very first thing that we have to talk about in this assignment is the grid. So I talked about this a little bit before, and the grid is essentially the data structure that we're using for this for this world. Okay, so let me really quickly, I have some slides that I want to go into that sort of explain the world for this assignment. So this is assignment 1. I just have a few slides that I want to go over because it's easier than having to redraw everything. So in assignment 1, again, we're using JavaScript and HTML. You are given the UI. You have to implement the algorithm. You are implementing path finding using breadth first search and depth first search. Very, very simple algorithms that I've already given to you. You are doing 4-directional grid movement, and the goal is to implement both BFS and DFS. The required JavaScript knowledge that you're going to need for this course: a very, very basic variable and object usage knowledge. I'll show you some of that when we get in there. You'll need for and while loops, if statements, arrays and 2D arrays, functions and classes, and the user interface knowledge is absolutely not necessary whatsoever. Okay, and I'll get into that once I open the file. If you do want to know more about how the visualization works, it uses something called Canvas to do the drawing. It uses HTML and CSS for the styling of the page, and it uses JavaScript for the algorithms. So I used, there's a really great series out there, and this is the playlist. This will be available on D2L for students in the class, or you can take a screenshot now if you want to. And this is a playlist of videos that show you how to set up HTML and Canvas if you want to know how the UI works. But you absolutely do not need to click this link or watch these videos. Just realize that if you want to know how the UI works, you can follow this if you want. Just keep in mind that the video uses some out-of-date JavaScript methods, but that's still fine. It still shows you. So here's the interface that we've been given for this assignment, and it uses a grid. Okay, so what is that grid? Well, the grid is essentially a 2-dimensional array, and each element of the array is a state of our environment. Okay, so for example, our agent can pathfind between locations on this grid. So these are the XY states of the environment, where the user or where the agent currently is. For our grid, the way that I have drawn this is that the 0, 0 coordinate of our grid is in the top left, because that's how Canvas and HTML work. So if you've done a math course or a geometry course, you might be used to XY being in the bottom left. Remember how you did the XY coordinate plane? If you're doing math, then XY is in the bottom left. When you're talking about user interfaces and graphics libraries, typically 0, 0 is in the top left. So the cell 0, 0 would be the topmost cell, As we move to the right, our x value increases. So then instead of 0, 0, if we move right, we'll be at 1, 0. If we move right again, we'll be at 2, 0. Then if we move down, because y increases downwards, we've gone from 2, 0 to 2, 1. Okay, so that's how the grid works. Now, how do we move around in this environment? So the legal actions that we have in this environment are moving up, down, left, and right by 1 square, okay, by 1 grid cell. So if we are at any given location in our grid, we can move up, down, left, or right, and the actions are going to be represented by the change in the x and y values from our starting state to our destination state. So for example, the action of moving right changes the x value by 1 and the y value by 0. Okay? So in order to calculate where you will land if you move to the right, you take your current xy position, you add 1 to x, and you add 0 to y. That's how you do it. On the other side, if you wanted to move left, you would subtract 1 from x and leave y by itself. If you want to move up, so let's do down first. So down, y increases downward in our environment. So you would add nothing to x, and you would add 1 to y to go down. And if you want to go up, x would stay the same, and you'd subtract 1 from y. So actions are represented by an xy pair. And in order to get from one location to another location, you add the actions values to your current position. Okay? So your current state, you're at xy. If you have an action, which is 1, 0, you add 1, 0 to xy to get the next state that you would be in. All right? Hopefully that's pretty intuitive. Next, we have action costs. Okay? Now, action costs in a pathfinding environment typically are indicative of how far that we've gone. In our action costs for this assignment, what we're doing is we're multiplying the distance by 100. So the cost of going one tile up, down, left, or right is 100. And the reason I've done that, I could have left it as 1, but in assignment 2, we're going to have diagonal actions. And in order to keep everything as nice integers, I want to have significant digits. So a diagonal will be 141 in the new assignment, which is the square root of 2 times 100. Don't worry about it. All you need to do in order to find the cost of an action is it's just 100 for this assignment. It's very, very easy. Okay. So what are legal actions in the context of this assignment? How can we actually move to do our pathfinding? First and foremost, the object must be within the map bounds. It means that if we're currently up here at the top of the map, we can't move up, right? Because there's nothing there. We have to only move within the bounds of the map. So we can't move below the bottom, above the top, or past the sides. Secondly, an object can only move in 4 directions. So up, down, left, and right. We've already talked about that. The object can only move to a space if it is the same color as where it is currently. And I'll give an example of that in a second. And an object cannot move off of the map. All right, so what does that mean? So for assignment 1, we only have objects of size 1. So we won't worry about size 2 until we get to assignment 2 in a few lectures. But for assignment 1, all of our objects are just living at a grid location. So for example, if this is my world, my object is living right here. It has size 1. It occupies one single XY location on the map. All right. So what are legal actions then? Let's talk about legal actions. If my object or my agent is currently right here on the map, it is occupying a blue tile. So if it's occupying a blue tile, it can only move to other blue tiles. So here are the legal actions for this tile in our, for this agent at this location within our environment. You can move up because it's still blue. You can move right because it's still blue. You can move down because it's still blue. but you can't move left because that would be moving from a blue location to a green location. Now, in the underlying representation, we're not storing colors. We're just storing integers, okay? So for example, blue might just be a 0 and green might just be a 1. So I'll show you how to get these values in a few minutes, but just realize that underneath this whole thing, the environment is just a 2D array of integers. And then when I go to the user interface, I say, okay, if it's a 0, color it blue. If it's a 1, color it green. If it's a 2, color it gray, for example, okay? So the colors don't actually have anything to do with the assignment. It's just a nicer way to visualize it for you. I have a node class. We'll talk about the node class in a little bit. And then also in these slides, which I'm going to give to you, I've also included assignment 1 breadth first search and assignment 1 depth first search. So these slides, these are just a slight explanation for assignment 1. I'll put them up on the spreadsheet and on D2L so you can have these as a reference for when you're doing the assignment. Great. So that explains what the grid is and the legal actions. So let me explain now, let me show you how that's sort of implemented. I need to view, is it Control Plus? Yes, it is. Perfect. All right. Hopefully this is big enough for you to see. So I am currently looking at the index.html file in the assignment. Now, you can do the entire assignment without knowing how this works. I just wanted to show you how the maps are stored, okay? So you can understand later with the grid. So here we have a blank map, and I've stored all of this data just in these blank text areas within the HTML file. So here is where the maps are actually stored. And you can see here that this is my L-shaped map. It consists of all 2s. Okay, so it turns out that 2 is blue and 0 is gray. That must mean that 1 is green. So here is how I've defined that map. Here's the default map. You can see how it looks. Actually, over on the corner, you can kind of see, because the font is so small, you can actually sort of see the GIF. Or not the GIF, but like the little image of that. So the grid is really simple. It's just integers, okay? And when you go to see whether or not an action is legal from my current XY location to another XY location, you're going to ask the grid, hey, is the place that I want to go to, does that have the same value as the place that I am right now? If they are, then yes, you can go there. If not, then you can't go there. Okay, so the grid is just a bunch of integers, and all the fancy colors are just how I've done that in the user interface. Over here on the left, I have a grid class. So just like if you've done any Python or Java, JavaScript has classes, and the classes are very similar to what you are already used to, apologies. So this class is just a grid. It is a class that essentially just holds the class holds a 2D array of values. So I have these values here in my HTML file, and the way that I give you access to them is I've created this grid class that you can use that gets set up via that text. So the constructor of the grid just takes in the map text. You don't have to worry about that. This is all done for you. So it just stores it in a 2D array. And then the two functions that you do want to worry about are the get function and the isOOB function. So the get function essentially just returns the value at that grid location. So if I say get 0, 2, that will give me the integer value at x location 0, y location 2 in the grid. Over here is the isOOB function, and that is the function that tells you, is this location out of bounds? What does that mean? Well, let me go back here. So if I query is out of bounds on a specific integer x and y location, that will essentially tell me whether or not that x and y goes off of the edge of the map. So it says, is x less than 0, or is y less than 0, or is y greater than the height of the map, or is x greater than the width of the map. So rather than have to have you implement that, I have that function already here, and it just does exactly what I just said. Now, this function has one extra parameter here, which is size. That's because we're going to use the same function for assignment 2. So whenever you call isOOB, please just pass in 1 as the size. That's very important. So you're going to say grid.isOOB xy1 for assignment 1, and then in assignment 2, we'll be utilizing that extra size variable. So that's the grid class. That's really the only other class that you need to know, other than the student class that I'll get to in a minute. Next, there are 2 user interface classes here. This is all just a bunch of helper classes and user interface code that I have set up here. It is hundreds of lines of code. I put a lot of effort into that. Please don't put this stuff online or I will come after you. And this basically just sets up the user interface, and you do not need to know how this works. You are completely free, if you want to play around with it. And, you know, you're always free to play around with code. However, you cannot make any modifications to this because you'll only be submitting the search student code when you submit your assignment. So this user interface code, the one thing that you do need to know about how it works is that this user interface essentially has 2 parts. It has the user interface and it has the algorithm code. Your algorithm code, the user interface is constantly polling your algorithm code. So for example, it'll say, hey, is there a path between these 2 things? And there's a function in your code that is being called that's just like the inner iteration of the search algorithm. And I'll show that in a minute. But essentially just realize that this interface is calling your algorithm. Okay? And it's doing so at 60 frames per second. So as fast as your code can run, that's what's happening here. So if you do the animated search here with the solution, then you are seeing this algorithm run at 60 frames per second, which would be equivalent to 60 nodes per second. Okay, let's go back. So that's what the user interface code does. It does everything for you. The only thing you have to do for this assignment is the breadth first search and the depth first search. And other assignments going forward in this course are going to use the exact same architecture. I will provide you with a user interface and you have to edit the algorithm, and that's it. Okie doke. So let's go here, and we will go into, first, the obfuscated solution code. So obfuscation is the process of sort of encrypting something, right? It's not a true encryption, but what it does is it makes it so this would be very, very hard for you to cheat off of. I really want to give you solution code so that you can run the program and see how it's supposed to work, okay? So what I've done is I've run this through some obfuscation things. It is possible to deobfuscate this and read it, but it will be gibberish. And I have actually had people in this class run my program through an obfuscate, like an automated deobfuscation program, and then submit my code back to me. If you do that, you will automatically receive a 0 for the entire course. You might as well drop the course if you try and do that. I will know if you have done it, and it will also be incorrect. Because the source code that this is obfuscating is a solution to assignment 2 that also happens to be a solution for assignment 1. So I'll just know, and you really shouldn't do it, so don't do that. So this is the solution code that has been obfuscated. All right, so let's look at the actual code that you have to do. First of all, let's read this. It says, all of your assignment 1 code should be in this file. It is the only file that is submitted. You may create additional functions or member variables within this class, but do not rename any of the existing class variables or function names, since they are used by the GUI to perform specific functions. your group only submits one file total, not one file per person. So make sure to enter both of your names above. When you receive this file, it will have all of your information already above, but please include, if you're working in a group of 2, please include your group members' names, both of your group members' names for the one person who submits the code, okay? So here's the class. This class is called searchStudent, and essentially what happens is when I have this user interface, when I have student BFS selected, it will use your class, and when I have solution BFS selected, it will use my class. So whenever you select this, that is when your student code gets instantiated, and then it starts running your solution code, or your student code. All right. There are a few class variables that you need to know in order for this to work. And these class variables are set by the user interface. So for example, some things that your search algorithm has to know are, for example, am I currently running BFS or DFS? What is the start location? What is the goal location? Okay, so all of those things need to be passed into your algorithm. And the user interface passes that into your algorithm for you, and then you need to set those variables. So for example, this.config contains a set of legal actions. So for example, as I said before, an action is an XY tuple, okay? So, I've got, one second here. I've got the Copilot plugin activated. So GitHub Copilot is like an AI add-in for this, and I've got it activated, but I'm gonna deactivate it now. Let's disable it globally because it puts in a bunch of it puts in a bunch of suggestions that would get very annoying while I'm typing this in. So, this.config is so if you've ever used Python, and in Python you had a class and it said self.variable name, that's what this.variable name is inside JavaScript, okay? And I think if you're using Java, it's also this dot, so you should be used to that by now. So this.config, that contains all of the different configuration options for the algorithm. So the first one is config.actions. So as I said before, there are 4 legal actions for this assignment: up, down, left, and right. Those actions are represented by an array with 2 elements, an X and a Y. So for example, an action left would be equal to -1 in the X direction and 0 in the Y direction. So that means that this.config.actions, so if I say this.config.actions, that is actually going to be equal to, say 0, 1, or 0, -1, that's up, then 0, 1, that's down, then -1, 0, that's right, that's left, and then 1, 0, that is right. Okay, so you do not need to type this in. This is already in there, and it's provided by the user interface. And so, but I'm just showing you that this.config.actions is an array of arrays where each element of the initial array is a smaller array containing the actions data. Okay, so that's what that is. This.config.action costs is an array containing the costs of each action. And for this assignment, the cost of every action is just 100. Okay, so that means that the first action, whatever that was, costs 100. The second one also costs 100. The third one costs 100, etc. And this.config.strategy is going to be a string either equal to BFS or DFS. And that, again, that is set over here in the user interface when I select this. And then in your algorithm, you're going to say, if this.config.strategy is BFS, do breadth first search. Otherwise, if it's DFS, do depth first search. Okie doke. Next variable, this.grid. That holds the grid data structure. So this grid class that we talked about, that is the grid for the current map. So if I want to get, for example, get the integer value of the grid at x equals 3, y equals 7, I would say this.grid.get 3, 7. Okay? If I want to know whether or not the location 3, 7 is out of bounds, I would say this.grid.isOOB 3, 7, and 1, because 1 is the size of my object. Okay, so later on in the algorithm, you are going to be using both of these functions, and that's how you use the this.grid object. Okie doke. Next, we have the starting location. So this.sx, that's this.startx, and this.startY. That is the x and y location of the starting state of the pathfinding. And gx and gy, similarly, are the goal location of the pathfinding. That is initially set to -1, which is off of the map, so we know there's no goal, or there's no path. So these are just initialized to -1. And also, this.cost, that is the total cost of the path that you have produced, okay? So after you run your algorithm and you have the total cost of your path, you're going to set this right here. All right, so we'll talk about that a bit later. And you have these variables down here. This is where you are going to store the path, okay? So the path is going to be an ordered sequence of actions. So the actions, like for example, if your path was move right, and then move right, and then move right, then that's what your path would look like. It would be 3 move right actions. So once you're finished your algorithm, you're going to set the this.path variable. Then you're going to have your open list, which stores nodes, and you're going to have your closed list, which stores states, okay? Alrighty. The very first thing that you need to do is implement the startSearch function. So let me go over quickly a list of functions that you're going to need to do for the assignment. So this is basically all the work you have to do for the assignment. First is the startSearch function. Next is the isLegalAction function. So you have to say whether or not you can currently move from the state that the agent is at to the state that you want to be at. And then there is the searchIteration function that provides, that is the algorithm, where you put the algorithm. I'll explain that in a bit. Next, you are going to write getOpen, which returns a list of states in the open list, and getClosed, which returns a list of states in the closed list. So 5 functions. 5 functions is what you have to write when you implement this. Okay. The first function that you have to write is called startSearch. So let's just read what you have to do for startSearch. Student to do, implement this function. And please, once you've finished your assignment, could you remove all of these comments like this, because we no longer need them when we mark them. So this function should set up all the necessary data structures to begin a new search. This includes, but is not limited to, setting the start and goal locations, resetting the open and closed lists, and resetting the path. I have provided a starting point, but it is not complete. So what does this mean with regards to our algorithm? Okay. So if we go back and we look at the algorithm, so here is our algorithm BFS, okay? There are 2 parts to the algorithm. The first part of the algorithm is the setting up of all your variables. So for example, the closed list, setting up the open list, maybe setting up the start location, setting up the goal location. The second part of the algorithm is the actual search itself. So we have this while true, and we have this that goes into the search. Inside the startSearch function, you are only doing this part of the algorithm, okay? you are not doing any of the search algorithm or any of the searching or any of the legal action generation. None of that is happening inside the startSearch function. What happens with the interface is when I select a start location, as soon as I click the goal location, that calls the startSearch function and that sets all the variables. Okay? So what do you have to do here? Well, we are passed in 4 arguments into the startSearch function. So the user interface calls the startSearch function, and it passes in the starting x and starting y. Those are 2 integers. That's the xy position of the start state. And it passes in gx and gy, which is the xy position of the goal state. Okay. So I've provided a bunch of this for you already. So for example, it just says this.sx equals sx. So it sets up the the class member variables of here's the starting location and here's the goal location. It also sets up an empty path. So whenever we start a new search, right, we have to empty out the paths from any previous searches. The other thing that it does is this thing here, which is this.inProgress. So what is that? Well, if I come back here and I look at solution BFS, and then I do animated search. So when I start the search, this.inProgress is set to true. Then what happens is every frame, so the user interface continuously calls your searchIteration function. The searchIteration function is all of the stuff in here in red. Okay? So every frame, you can see that it's continuing with the search. And so in the algorithm here, this while true, this might as well say while this.inProgress. That's the thing that we're doing here. It's a variable that the user interface calls to know whether or not your search is still happening or not. And as soon as your function, your search, finds a path, so this will happen pretty quickly. You can actually speed it up over here if you want. This.inProgress is set to false, and the user interface knows that the search is no longer happening. Okay. So that's what this function does, startSearch. What you have to do is reset the open and closed lists, and then create the root node and add it to the open list. Okay? So what is a node? Remember, we have X, Y states. States are part of the environment. And we also have nodes in the search tree. So that's important. The node class is here for you. You don't need to add anything to this if you don't want to. A node takes in a state, so an X and a Y location, as well as the action that generated that node, and the parent of this node itself. So which node created this node? So what you have to do up here is after you've created the open and closed list, like for example, I'm not going to say that this is correct, but I'm just showing you an example. This.open equals this, okay? So this is this.open. That is resetting the open list. It's just blank right now. Maybe you want some other data structure. I'm not sure. What you have to do then is you are going to create the root node variable. And the root node variable is a node that is created on the starting state. So let's create a variable in JavaScript. We're going to say let root node equal. Now, many people would put var. So if you've done JavaScript in the past, you may have seen people say var root node. JavaScript is not statically typed. The type of things can change, but we are going to use let instead of var. I cannot explain to you how frustrating it is to debug this code if you use var. And the reason is something I cannot fully explain, but it has to do with JavaScript and how it scopes variables when you use var. If you use var, it's some sort of weird global scope and variables can like overwrite each other, etc., etc. The point of this whole thing is just to say always use let, and then your variables will have the scope that you're used to. Okay, so just like the scope of this let variable will be this function, just like you're used to in Python, just like you're used to in Java. Okay, so we are going to create a new node. There we go. So this is how JavaScript, how you create new variables. So let root node equals new node, and the node class, which is down here, takes in 4 things. It's going to take in an X, a Y, an action, and a parent. Okay, so what are we going to do? Well, we have the X and the Y are the starting X and the starting Y. That's pretty easy because our root node is of the starting state. Now, you also have an action. What is the action that created this node? Well, since it's the root node, it doesn't really have an action. So you can just say null. I've null created this action. Or you could even put in like 0, 0 if you want to, as long as you don't put in like an actual action. So no action produced this node because it's the root node. So nothing came above it. And what is the last thing? The last thing is the parent node. And no, the root node has no parent node. And so we would say null here. Okay? So that is how we set up the root node. And this is true. Like this is the actual solution. Once you have your open list, you are going to then say this.open.push root node. Similarly, you could have said this.open equals, and then inside the brackets, you can do this. Okay? So this is sort of a shorthand, but I wanted to show you how you would set up the node. So this is fine as well. You set up an open list, you are putting nodes inside that open list, etc. Now, when it comes to the closed list, you're storing states in the closed list. Okay? So if you did set up this.closed to be a blank list, if you ever did say let state equals we have like 310, for example. Let's say we're at the location 310, and our algorithm, which is right here, calls for adding that state to the closed list. How would I do that? So if we're back here, let's say we want to use the state from the root node and add that to the closed list. Now, we don't want to do that. I'm just showing you this example, okay? So we have this state. So inside the closed list, we would say we are going to add a new state. So, well, okay, we have the closed list. Now we say this.closed.push, because that's how we add to something. And now in here, we are going to want to add an XY state. So what is the X? Well, that is root node.x and root node.y. So that is one way that you could store states in the closed list. All right. So the closed list is going to be a list of XY locations. And then later on, when you go to check to see if something is in the closed list, you're going to check those locations. So that is how you would set up the root node and add it to the open list. And this is how you would set up the closed list and add things to the closed list later. Cool. So that you have to do, but that I just showed you how to do. The next thing is to actually produce the legal actions. So you have to create that, well, you have to fill out this function, which is called isLegalAction. And let's read it. So this function should compute whether or not the given action is able to be performed from the given XY location. The arguments are XY, 2 integers representing the XY location of a given position in the grid. And then we have an action, and the action is an array containing an X and a Y, right? So the action to be performed representing the XY movement from this position. For example, 1, 0 is move 1 in the X direction and 0 in the Y direction. For this assignment, the only actions possible should be this, right? So down here in the isLegalAction, you have to return a Boolean, which is true if the action is legal and false if the action is not legal. So how do we do that? Well, I've given you a little bit of helper code here. So let's compute the next x and the next y. So here we have an xy and an action. So from this xy, I'm going to take the xy component of the action and add them to that x and y. So if I want to find the next x and the next y, well, the next x is just x plus the first element of that action array. And the next y is just y plus the first element of that action array. So the first thing you have to do is create an x and an y, which I have already done for you. Then you call to see if that next xy location is out of bounds. If it is out of bounds, return false. And remember, you have to put this 1 in here as well, right? And then the only other thing you have to do is check to see if this .grid.getXy, which is the original position, does that have the same value as this .grid.getNX and y? So what does that mean? It means this. So if I was right here, right, if I was on this yellow tile, this is xy. If I want to move left, then I would do -1, 0. So I'd have x plus -1, y plus 0. And then I would check with the grid to say, is the color that I came from the same as the color that I'm going to? And if it's not, then it is not a legal action. Okay. Someone in the chat just asked a question. Can I write a project based on your videos? You can do whatever you want with my videos. That's fine. Just realize that you can do whatever you want with the things that you learn from my videos. But I can't give anyone the assignment files. That's all. Okie doke. So that's it. You just write 2 more lines of code and the isLegalAction function is done for you. You have to check if grid.is out of bounds or if the 2 colors are the same. So the last thing that you have to write is the main part of the assignment, which is the searchIteration function. Okay, so let's read searchIteration because it's not complicated, it's not complex, it's just a lot to it, right? So this function performs 1 iteration of search, which is equivalent to everything inside the while true part of the algorithm pseudocode in the class. The only difference being that when a path is found, we set the internal path variable rather than returning it from the function. What does that mean? Well, it essentially means that inside this function, the searchIteration function, you are putting all of this in red. You are not putting the while true because the while true is essentially done by the user interface, okay? You are putting all of this code. And what you can do is hit Control-C, go over here, hit Control-V, and then just turn that into JavaScript. I'm not joking when I say that it's that easy. You just take this and you turn that into JavaScript. Done. It's written in pseudocode right now, but it's in JavaScript. All right. So, second paragraph. If the search has been complete... Oh, sorry, I didn't read this. When expanding the current node, you must use the this.isLegalAction function above. So wherever you go to generate your children, and I'll talk about that in a bit, you are going to use the this.isLegalAction function. And I'll show you an example of that. If the search has been completed, either the path has been found or the list is empty, then this function should do nothing until the startSearch function has been called again. This function should correctly set this.inProgress variable to false once the search has been completed, which is required for the GUI to function properly. So what that means is that the user interface is going to call this thing, okay? And it needs to know, okay, the search has started, it's in progress, now the search is finished, it's not in progress. So all you have to do over here, instead of returning, we are not going to be returning in our code. You're just going to be setting this.inProgress to false. So whenever you find, if you find that the open list is empty, that's it. Just this.inProgress equals false. If you find a solution, instead of returning the solution, you're going to set this .path to the solution, okay? This function should perform one iteration of breadth first search if this.config.strategy variable equals BFS, or one iteration of depth first search if this.config.strategy equals DFS. There should be a few lines of code difference between the two algorithms, right? Look at this. Here's BFS, here's DFS. All you have to do for BFS is use a queue, and all you have to do for DFS is use a stack. If you do this properly, you should have one line of code difference between BFS and DFS. So here's a tip for you. So you say, okay, this is a stack and this is a queue. How do I make a stack or a queue? It turns out that JavaScript will do this for you automatically. So you can use a JavaScript array to represent a queue or a stack. So let's look at the difference between a queue and a stack again. And to do that, we are going to go to my magical blackboard. All right. So here's the blackboard. I'm going to go over stack versus queue again. So here is one array. Let me change that size. And here is another array. All right. So now we go over here. This is going to be a queue, UE, UE. And this is going to be a stack. There you go. So when you use a queue and you put an element onto a queue, let me copy and paste something. So this is going to be an element E. Here we go. Queues are first in, first out, right? So if I have something here, I'm going to put it, if I push it onto the queue, it goes onto the end of the queue as normal. So I'm pushing things onto the queue, right? I'm pushing things onto the queue. Sorry, this is a bit tedious. So I push things onto the queue like that. Now, when I go to pop something off of a queue, it's this element that gets removed. Okay? So, yeah, you might have to create like a data structure that does this, but it turns out in JavaScript, if you want to use an array like a queue, well, to add to the end of the queue, you use array.push. And if you want to remove the first element of the array, you can just say array.shift. So for your BFS, you want to use array.shift. If you want to use DFS, it's array.pop. Why is it array.pop? It's because for a stack, what you're doing is you are putting things onto the stack. And then when you pop from a stack, you're popping from the end of the stack. And so array.pop will remove from the end of an array. Array.shift will remove from the beginning of an array. So you can use standard JavaScript arrays to simulate a queue or a stack. It's just that queue is for DFS, so you're going to be using array.shift. And sorry, no, queue is for BFS, right? Let's look back at our code. Yeah, queue is for BFS, meaning that the first thing we insert is the first thing we're going to pop off. And for the stack, that's for DFS, so we're going to use pop. So just to reiterate, use JavaScript arrays for both, use shift to simulate a queue for BFS, and use pop to simulate a stack for DFS. Alrighty, let's go back to the code. So that's what this says, but it also says, hey, if you have your own custom data structure, be my guest, okay? You can use that if you want. This does not return anything, and it takes no arguments. Alrighty. So the search iteration function, again, to drive it home, it is this code and nothing more than that code. That's all that goes there. Example. But of course, the code here does something more. Like your student code, as I've given you, creates this weird L-shaped path. How does it do that? Okay, we'll show you how it does that. For simple demonstration, The code that I've given you computes an L-shaped path to the goal. This is just so the GUI shows something when the student code is initially selected. Completely delete all of this code in this function and write your own solution. So what I mean by that is delete all of this code. All right? Delete all of that code. Just do that and start writing your solution. Got it? Sure. All right. So what does this do though? Oh, look at this. I put var in here. These should all be let. Oh no. It's just the code that you're going to delete anyway, but I still feel kind of bad. So this creates an L-shaped path. I will leave it up to you to investigate how it does that. But essentially, the important part is to show this right here. Whenever you want to add an action to your path, you are going to say this.path.push and then the action. Okay, so let's delete this. And now let's write something that will always return a path that says go to the right 10 times. Okay, so let's go for let I equal 0, I less than 10, I plus plus. How do we create a path? And we're not returning anything, remember. We are going to say this.path.push 1, 0. See that? So I'm pushing to the path an array which has an X and a Y. That's it. Down here, I'll get to that in a second. But that's all that this does. So now if I've made a change to my code, so I'm going to hit Control S to save. All I need to do is refresh the web page. Okay? Once I refresh the web page, it reloads the JavaScript. There's no compiling, there's no anything. So now, if I select a start and a goal, see that? It always, no matter what, just shows a path that goes to the right by 10. So that's what a path is. It's an ordered sequence of actions. And here, let me just put in a few more things. So let me put in right and then down. So down would be 0, 1. So now this would go right down, right down, right down 10 times. So let's have a look at that. Here we go. So that goes right down, right down, right down. See how that works? That's pretty cool. So that's how we do it. We set the this.path variable, and then the user interface knows how to draw that. Perfect. So let's erase that, and we will go on with our code. Here, I've put in the code for you that reads the this.config.strategy as BFS or DFS. So in here, you would do your depth first or breadth first search, and in here, you would do your depth first search. Okay? Now, note, do not duplicate all of your BFS code in the if statement above. You should only include what is different between the two algorithms. Okay? So I'll show you that in a bit, but essentially, if you look back at your algorithm here, all you need to do, the only change between BFS and DFS is here you're calling in JavaScript for BFS for a queue, you would call .shift, and for DFS, you would call .pop. Those are the only differences. So you don't need to copy all of this and put it in two places. Okay, you would just use the first one. So let's do exactly what I said. Let's give you a big hint on the assignment. I am going to copy, literally copy from this slide, and I'm going to put it into here. All right. So let's say for now that I'm only doing BFS. I'm not taking this into account. What is the search iteration function going to do? Well, it's going to do these things. The first thing it's going to do is to check to see if the open list is empty. So if the open list is empty, meaning it has no elements, then I haven't found a path yet. So in here, now I'm not saying that this is correct. I am not going to be translating this into JavaScript for you because that is literally doing the assignment for you. But here, if the open list is empty, stop the search. So how do we do that? Well, we are doing that in this assignment by saying this dot in progress equals false. So if we want to, if we haven't found a path, then all we have to do is, in this interface at least, all we have to do is say the search is over because the current path is empty anyway, right? And the only other thing is that if you look really closely at the solution code, if I run the tests, if a path is not possible, then that means the cost is -1. That's just, if the path is not possible, the cost is -1. So here we would say this dot cost equals -1. So I've done that for you, okay? Now, of course, this is this dot open, and it might not be this dot open dot empty, it might be something else, all right? But that's the very first thing that we check is whether or not the open list is empty, and then we stop the search if it is. The next thing we do, let's look at our code. Node equals open.pop. So let's just pretend we're doing BFS, right? And so we need to get the thing from the front of the queue. So we can say let node equals this dot open dot, and because this is BFS, it is shift, all right? So this will work if you are using JavaScript arrays for your open list. So that's what this is. Get the next node to expand. That's what that is. Here, this says, if the state of this node is the goal, set the solution path. So here, we're not saying if node.state is goal. That is very obviously not correct JavaScript. But what you would say is something like, if node.x equals this.gx and node.y equals this.gy. That is how we do the goal test. If the state of this node is equal to the goal, then we return the solution. But of course, and of course I have more stuff in here, right? But I'm not going to do that. I'm just going to leave it like that. And instead of returning solution, what we have to do here is compute the path. So once we get to the goal node, how do we compute the path? Let me show you with the Blackboard. All right, so let me erase all this stuff. And let's pretend that we have some nodes here. I'm going to use white to save the colorblind people. So let's say this is our root node. And then we've gone to another node, and then gone to another node, and gone to another node, right? So we have this sort of structure in our search. This link here, I can get back to the parent of this node by following the parent pointer back to here. Then I can get to the parent of this node by going to here, and the parent of this node by going to here. Now, if we remember, the nodes store X, Y state, they store action, and they store parent. Okay? So what I can do is, if we remember, the parent of the root node is null. So if I'm at a current node and I've found the goal, I can say work backwards through the parent pointers. So if, and then so I get this parent, I get here, now I know the action, right? So I know the action that produced this, I go back. I know the action that produced this, I go back. I know the action that produces this, I go back. And what I do here is I test to see if the parent is null. And when the parent is null, it means, oh, I've reached the starting location. So what you can do is something like the following. So you can say, let, so I've got my current node right here, okay? So this is the node that is the goal. So down here, I can do this in a number of different ways, but I can say while node.parent is not equal to null. Now, again, Oh, sorry. Thank you. I didn't switch screens. All right. So what I can do here, this is why the live chat is so great. So the way that I can do that going backwards through the parent pointers is I keep going until the parent is null. So I can say while parent or node.parent is not equal to null, right? Well, actually, what I want to do is set up a temporary variable. So let's say new node or next node. Yeah, let's do next node. So we're going to set next node equal to the original node. Then while next node dot parent is not equal to null, what am I going to do? Well, what I'm currently doing is I'm currently looking at one of the nodes in the search path. And what I'm actually trying to do here is get the actions that produce this path. So the action that produced this is nextNode.action. So that's the action. So what I could do is say this.path.push this action. It's really that simple. So we go back up through, and the last thing we have to do is after we've gotten the action, we say next node equals next node.parent. There we go. So this code may not work line for line exactly, but it essentially crawls back through the nodes until we reach a null parent, meaning that we are at the start. Okay? So this is how you do that. And here is one additional thing. Watch this. If I crawl back through like this, what have I actually produced? Well, this is the final action, then the second final action, then so I've actually produced the path in reverse if I do it this way. So what I have to do is down here, I now have to reverse this dot path. So if you do it this way, just realize that you've created the path in reverse, and now you have to reverse the path. Otherwise, it's going to be going in the opposite direction in the user interface. All right, so that's this part of the code. Now, down here, once we've checked, okay, if this fails, then the node is not the goal. Oh, sorry, the last thing we have to do, of course, this.inProgress equals false. And then we can also return. All right, so we can return whenever we set this.progress equals false. And we can return here as well. So that's just something to add. This means that the search is over. But if the search is not over, we have to continue on with the algorithm. So what we just wrote is this. We just wrote, if we've reached the goal, return the solution. However, instead of returning a solution, we are actually going to be setting the path variable. The next thing we have to do is this part. If the state of this node is in the closed list, then I don't want to continue. Okay? So let's do that. So if node.state is in closed, continue. How would I actually do that? Well, you can do that in a number of different ways. However, I want to make something very, very clear because this is a big, this is a JavaScript specific thing, and it has caused many people to beat their heads against a wall. Let's say that I have a number of actions, okay? So I'm going to say actions equal 1, or this is a number of states. So states, maybe this is like 1, 2, and then I have 3, 4, and then I have like 7, 10. So let's say that that is some, that is some array of states, and those states are arrays. So this is what our closed list is going to look like. It's going to be an array of arrays. So that's what it's going to look like. Now, let's say I have check state, which is equal to 3, 4. How would I write an algorithm to check to see whether or not this state is inside this collection of states, right? This is what I'm saying. If the state is in the closed list. Now, you may go out there and Google, how to find, an array element inside an array or whatever. Maybe there's an array.contains or something like that. Here's the tricky part. let's write a for loop together. For let I equals 0, I is less than states.length I++. This is how you iterate an array in JavaScript. Okay? If I say if states I is equal to check state, who can tell me what's wrong with this? Does anyone out there know? I'm curious if anyone out there knows. So I'm trying to see if this state exists as an element of these states. This is probably what you would write naively, right? It makes sense if this state is equal to the state in the array. However, no one has said anything, and that's very telling. In JavaScript, if you have if you have arrays, if I compare this array to that array, what you would think is actually happening is an element by element comparison. And so as a human, we would say, is check state inside states? Yes, of course it is. Look, it's right there. 3, 4 is inside the array right there. However, what this JavaScript statement is saying is this array exactly equal to that array? Meaning, is it the same literal array in memory? And no, it is not. Because if I modified this array, I would not be modifying this array. Okay? So this check will never be true, even if check state contains the same elements as this. It's super annoying. So what you have to do is you have to specifically spell it out and say if check state.x is equal to states I.x and check state.y is equal to states I, it's not .x, it's I0, and this is equal to I1. So for each element in the array, these are arrays as well. So you have to do the element by element comparison. And again, this is 0. Apologies, there's no X and Y element. You have to do this, all right? So just realize that you could write this, you could copy and paste that and start your algorithm like this. Or, I mean, you could put this into its own function, right? You could put this into its own function. Let's see how you might do that. You could come down here and you could write your own function. So maybe this is like check in closed, and this would be int x, int y. So down here, you would copy and paste this. There's no ints because it's not typed. So we would have an x and a y. And instead of saying here, check state 0, well, now we would have x, check state 1, we would have y. And instead of saying states, we would have this dot closed. All right, so this is how you would write a function to check to see if this particular state with this x and y is actually inside the closed list. And if it is, then you would return true. And if not, then you would return false. I know it doesn't say false, but I don't want to do the assignment for you, but that's how you would do that. All right. So if we do find in here, so if we do have that function, you could say if this dot is in closed list node, right? We're checking this node, node.x, node.y. Then instead of continuing, because continue is what happens when we're inside a loop, but this is not inside a loop, we would return here, okay? So that is this line of the function. So that's what we have there. So let's delete all of that. We just wrote this function. Now, if it's not in the closed list, we have to do two more things. We have to add it to the closed list and then expand. All right, so let's go do that. So closed.add node.state, that's really, really easy. It's just like this.closed.push node.x, node.y. That's literally the solution, so there you go. The last thing we have to do is, let me put this back to pseudocode, is open.add expand node problem. What does that mean? Well, if we go here, there was some code for that, but let's just write our own code for this, okay? I'm going to basically be doing a lot of this assignment for you, but this is all about getting used to it. It's not worth a ton of the year. It's just getting used to this stuff. So let's do something for you. What we want to do here is generate the children of node and add them to the open list. So the first thing that we want to do is get the legal actions, right? So how do I generate the children of a node? Well, generating the children of a node, so if I'm here, for example, I'm going to be generating this spot, and this spot, and then creating their nodes and adding those to the open list. So how would I do that? Well, the first thing I'm going to want to do is iterate over the legal actions. So as I said before, the legal actions is in this .config.actions. So let's look at that. For let a equals 0, a is less than this .config.actions.length a++. So this is the loop variable that we are using. And now we can say let action equal this .config.actions a. So that's the action. That is the XY array. That is our action. So what do we have to do? Well, what we want to do is figure out first, is this a legal action, right? And the place that we're coming from is the X and Y of the node. So we could ask, we have this function that we wrote up here, is legal action, right? So you would say, if not this dot is legal action, node.x, node.y, and action, then continue, right? So if this is not a legal action, then I do not want to create the child that's created by this action. There. So again, if not a legal action, continue. Otherwise, it is a legal action. So what we want to do here is generate the nx, ny, next state, right? Generate the new node. Okay. Then inside the new node, we have nx, ny, the action that created it, and the parent, which is the node itself. Okay. And then add that new node to the open list. Perfect. Done. I'm not going to do that for you because that would literally be doing the entire assignment for you. And then what you can do is where you have to do BFS versus DFS, okay? You take this up here where I said let node equals this.open.shift. You replace it here. If it's BFS, you say shift. If it's DFS, you say pop. That's how you do this. You do not rewrite all of this code inside both of those if statements. Okay? So I don't want to see the whole algorithm inside here. I want to see only the part that differs inside there. Then you need to have the path length. So the cost of the path, well, all of the actions in this assignment are of cost 100. So it's just the path length times 100. All right? And when you find a path, you set in progress to false. So what we want to do here is this is the cost of the path. You actually want to take this and put this in when you find the solution, not at the bottom of this function. So that's what the function is. And you have now like probably over half of the assignment literally done by me for you. So the last thing you have to do is the following: the getOpen and the getClosed list. And the getOpen and getClosed list functions are used by the user interface to draw the open and the closed list. So this red here, if I use a bit of a better example, actually, here we go. So the user interface wants to draw the closed list and the open list. The closed list is in red. The open list is in yellow, and all the user interface needs is a collection or an array of XY states that are in the open list and the closed list. So in here, what you have to do is you have to return an array of states in the closed list. It turns out that if you used a JavaScript array for the closed list, then all you have to do is return this.closed, because the this.closed is already an array of XY states. Okay? However, for the open list, your open list stores nodes, right? So open list stores nodes, not states. So what you have to do here is take each node from open and add its state to a new array. So you could say let open states equal a new array. Then for each node in open, add node.x, node.y to open states, and then return open states. This is the entire function, and you have to do this for getOpen. However, if you already have the closed list as that, then you just need to return the closed list. Otherwise, you would have to do something similar down here. And that is assignment 1. Now, future assignments will use the exact same architecture. So this went a little bit long because I had to explain the architecture to you. But just keep in mind that you have 1 week to do this assignment. Start it very soon. I am always available for questions. Well, not always. I am available for questions. You can email me. You can DM me. What I would recommend is that if you have a problem that's not specific to you somehow, post it in the general channel on Discord, and I will get to it, and that way everyone will see the answer. If someone asks a question and they are asking like, how do you do this? Please do not post solution code to the Discord. If you post solution code to the Discord, I will remove you from the Discord, okay? Or give you a very stern warning. So please do not that. That is academic misconduct. However, if it's like, hey, how do we open the HTML file? Or I have this error, how do I fix it? Then that is something that you can post there. I want to do one more thing when it comes to JavaScript here. So let me undo a lot of this stuff because this is not going to run properly. So I have to undo back to the point where you have that code. Come on. The original code that I did. All right, perfect. So now let me just reload this. All right, so, okay, perfect. When you're writing JavaScript, or when you are writing any code, and I'll tag this at the end as like a JavaScript debugging session, you're going to need to be able to print to a console. Like the user interface it's so good for debugging, right? The UI is amazing for debugging algorithms. However, you're also probably going to want to be able to print something and then see your print statement. So for example, let's say that when we call startSearch, we want to be able to print out somehow that our search has started. Or let's print out SX, SY, GX, and GY. Okay, let's print that out to the console. The way we do that in JavaScript is we say console.log, and then I can just say GX, GY, or SX, SY, SY, GX, GY. And what that will do is whenever we start a new search, it will print out the start and end to the console. So let's do that. So I'm going to refresh so that my changes have been saved. Now I'm going to open up the console. In Firefox, the shortcut to open up the console is Control-Shift-K. The console is now over here, okay? Right where my face is, unfortunately. If you're using Chrome, instead of Control-Shift-K, it's Control-Shift-J. All right? So Chrome is Control-Shift-J, Firefox Control-Shift-K. So now, my face is going to cover this up. So let me hide my face for a second. Over here on the right-hand side, this is the console. Any console.log statements will appear here. And you can see that actually one of those statements has already appeared. And there was a search started as soon as the user interface went live, but it was to a non-existent location. So what I'm going to do is when I select a start location and a goal location, now you can see that startSearch is printed. And it turns out that because of my bad UI code, if I just select a start location, it's actually calling a startSearch, but it's the goal location is the same as the end location, as the start location. Okay. So if I click and drag around, you can see that whenever it starts a new search, right, a new start and a new end, it is printing it out to the console. There's another way that you can do this. Printing to the console is quite nice. However, if you want a print statement that will actually stop all of the JavaScript on the page and you have to click a button, you can say alert. So you can say alert, and then this will happen. So when I reload, it'll say alert. Okay, actually that didn't work because alert expects a string. So let message equals this plus gx plus this plus gy. All right, so that's my message. And now I'm going to alert message. So when I start, I'm going to get the message. It's going to alert. Nothing else will run until I click OK. Now, whenever I click, it alerts me, okay? And then, you know, some sites use alerts very annoyingly. Now I'm going to click another one. It will alert, and you can see the path hasn't drawn yet because it actually pauses the JavaScript until I do it. So if you want to be able to print to the console, you can do that. Printing to the console is non-blocking. Alerting, as you can see, is blocking, meaning that no further JavaScript code will execute until you actually click yes to the alert or click OK to the alert. You can also, this is kind of amazing, actually, console.log, if you console.log an object, the object will be printed in the console and you can actually look at the entire object. So I have printed this.config. Let me hide my face again. This is super small. I apologize. I don't know how to make this bigger because it's all the way over here. Oh, look at that. I did it. Sweet. So I printed the console. Hey, I can get my camera back. I printed this.config and it printed an object to the screen. Look at this. So the object, it has an actions array. It prints out all the things in that array. I can actually do it like this. It gives me all the cool details. The strategy is currently BFS. The costs array is there. It has a bunch of other details, but you can print out whole objects to the console as well if you want to debug them that way. So if you, for example, if you're wondering like, why the hell, what's up with my open list? You can say console.log this.open. And then you come back and it will print this.open, which is an array of length 0. So you can say, oh, okay, my array is weird. It's empty. Maybe it shouldn't be empty at this point. All right. So that sometimes I forget to say that and people are like, how do I debug my JavaScript? And so that is how you would help to debug your JavaScript. Whew, that's it. That went a little bit long, but again, it's just assignment 1. It had a lot of the setup stuff and, you know, explaining what the UI did. All future assignments won't have to have that. So I know that every single lecture so far, I've been saying that, you know, oh, it's not going to go longer. But if we look down here, I give you an entire lecture off to study and stuff. So the average of all the lectures will be the standard hour and 20 minutes, I promise you. Great. That's assignment 1. It should be available right now. The link that I sent to your email should work, and you should be able to go and work on assignment 1. So find your partner if you're getting one. If you're not sure if you want a partner, do assignment 1 first, because it's a great judge of how much work it is. Like, assignment 1 is about 1/3 the work of assignment 2. So if you found yourself struggling with assignment 1, you 1000% need a partner for this course, or it's going to be very, very difficult for you going forward. And next week, I will have an office hour on Discord that you can join for help with the assignment. So thank you all so much for tuning in. That is assignment 1, and I'll see you next week for the next lecture. Thanks so much.